Hey guys, this is Mrs. Keith, and I'm going to do a video over this extra practice that we have today, just so that in case y'all have any questions, you can kind of get some answers on your own if you need it and you're not able to come to tutorials. So anyway, this first question says that we're asked to find the lateral area and let me change it. I'm sorry, my pen wasn't working. Find the lateral area, the surface area, and the volume for each of these. So we've got a cube. You'll have to excuse my drawings, they won't be the best. Its base has a perimeter of 28. So if the base has a perimeter of 28, that you've got four sides that make that up. So what I'm going to do first is I'm going to divide 28 divided by four sides gives me that each side length is 7. So each of these are 7 right here. All right. So things that you need for your formulas are you're going to need the area of your base. Well, your base is a square. And so you can do base times height or just do the side squared, but you're going to be doing 7 times 7, which is 49. So that's our area of the base. You also need the perimeter of your base, which they already told you was 28. And you need the height of your cube, which it's a cube, which means everything is the same length. So this height is also 7. So the height of that cube is 7. Okay. Now technically a cube is a prism. It's it has two bases and rectangle faces technically. So when you find your lateral area, you're going to be using the formula perimeter times the height. So we're going to be doing 28 times 7. And we get 196 feet squared. They told us it was in feet, so that'll be feet squared since we're multiplying two dimensions together like that. All right, total surface area. Our formula is the lateral area plus 2 times the area of the base. Well, we just found out our lateral area was 196. And then we wrote over here that the area of one base was 49, so we're taking care of both of them by multiplying it by 2. And so when you calculate that, you get 294, again, feet squared. Units for area is always going to be squared. All right, your volume is the area of your base times your height. The area of your base is 49. The height of this prism or cube is 7. And when you multiply those together, you get 343. The units for volume is always feet cubed, or units cubed, whatever the units are. All right, so that's your number 1. Number 2 has a prism with bases that are equilateral triangles with sides of 12 centimeters and a height of 20 centimeters. All right, so we've got an equilateral triangle. And it's a prism, which means you have rectangle faces. All right, they tell you that the sides of this triangle are 12, and they tell you the height of the prism is 20. Remember, the height is always the distance between your parallel bases. So this should be our figure. Let's see if I can just finish drawing this. All right, so we have to find our capital B, which would be the area of this face right here. So we've got to find, the area of this base. We've got to find the area of that base, which is an equilateral triangle. So let's just think about, I'm going to kind of draw that separately. All of your sides are 12 because it's equilateral. When I draw the height that's going to be perpendicular to that base, it's going to break that base up into 2 equal parts. Because it's equilateral, that's always going to happen. All right, we need to figure out, because when you do your capital B, that's the area of a triangle because your base is a triangle. So you're going to be doing 1/2 base times height. We know the base of this triangle, it's 12. We need to know the height. So I'm going to have to do the Pythagorean theorem to figure that out. So I'll do 6 squared plus h squared equals 12 squared. And when you do that, you're going to be doing 144 minus 36. And so you get the h is the square root of 108. So then you're going to end up, what I'm going to do is I'm just going to simplify that radical. So that's the square root of 36 times the square root of 3, which makes that simplify to be 6 square root of 3. So that's a simplified radical. So that's the height of the triangle, not the prism, but the triangle. And so whenever I do my area of my base, I'm doing 1/2 times 12 times that 6 square root of 3. Okay, so now if I calculate that, what I'm going to do is 1/2 times 12, that's 6, and then 6 times 6 is 36, and then that's times the square root of 3. So the area of your base is 36 square root of 3. And I'm going to write that over here. So the area of my base is 36 square root of 3. All right, now then, I need to know what the perimeter of that base is. Well, I've got 3 sides that are each 12. This is 12, this is 12, and this is 12. So to get my perimeter, I'm going to be doing 12 times 3 to be 36. So 36 is my perimeter. All right, and then the height of that prism is 20, is what they told me. All right, I'm going to erase some of the stuff in the middle just to give myself some more room. So hopefully you can rewind this if you need to see what that is. Okay, so now then my formulas are lateral area, it's the perimeter times the height. The perimeter we found out was 36. The height is 20. And when I multiply that out, I get 720 centimeters squared. So that's your lateral area. Okay, your total surface area will be the lateral area plus 2 times the area of your base. So that's 720 plus 2 times 36 square root of 3. So that's 720. When you multiply 2 times, you're just multiplying the 2 times the 36. So that's going to be 72 square root of 3. And then you cannot add those two together. I mean, you could in a calculator, but you shouldn't add those two together. You can't say 720 plus 72 because the 720 doesn't have a square root of 3 attached to it. So if we ask you to leave your answer exact, that's going to be your answer. I probably should write centimeters squared there. But that would be your answer for an exact answer. You could type that in your calculator, and if we ask you to round, to give us a rounded decimal, I believe it becomes 844.708 when you type that in your calculator. But a lot of times we're going to ask you to leave your answer exact, and that's when you don't get a rounded off decimal. All right, then we're going to do our volume. Our volume is the area of the base times the height. So my base again was 36 square root of 3 times the height, which is 20. And all you're really multiplying is this 36 and the 20. And so that gives you 720 square root of 3. And then that would be your answer for that. So that would be centimeters cubed. If you did multiply it out in the calculator, if we ask you to round to thousands, for example, you would say 1,247.077. All right, let's move on. I'm going to erase all this and move it down a little bit. Okay, on number 3, we have a cone. Remember, a cone is basically a circular pyramid. And they're telling us that the radius is 3. That's right here. That's 3. And then they tell us that our height is 4. Remember, your height is drawn from that vertex up there, perpendicular to that base. I don't know why I wrote the height. Sorry. I meant to write what the actual height was, which was 4. And then again, it's perpendicular to that base down there. Okay, so our formula for a cone, we've got the lateral areas formula, and that is going to be pi RL, and then we've got the surface area formula, which takes your lateral area, the pi RL, and it adds the area of the base, which is a circle, so pi r squared. And then you've got your volume formula, which is 1/3 pi r squared h. Okay, so you're going to need that lateral height. This right here, that's your lateral height. So you're going to have to do the Pythagorean theorem to get that. So we'll do 3 squared plus 4 squared equals that L squared. And so you'll end up getting that this lateral height over here is 5. All right, so then we plug it into our formula. Our lateral area will be pi times my radius, which is 3, times that lateral height, which is 5. And we're going to be asking you to leave your answer exact or leave it in terms of pi. So you're going to say your answer is 15 pi. And then our units are going to be feet squared. All right, so that's our lateral area. Our total surface area takes that lateral area, so 15 pi plus pi times the radius squared. So that's going to be 15 pi plus 9 pi, which adds up to be 24 pi. So that's going to be 24 pi feet squared again. All right, our volume is 1/3 pi, and then my radius is 3. They ask us to square that, times the height, which is 4. And then we'll do 1/3 pi. When you do that, you get 9 times 4, which is 36. And now you're doing 1/3 of 36, which is like saying 36 divided by 3. So that's 12 pi. And then my units are feet cubed. And that's our volume. Okay, let's do number 4. So number 4, we have a cylinder. And they tell us that our, let's see, our diameter is 10, which means my radius is just 5. And then my height is 15. All right, and I'm going to write down the formulas. We've got the lateral area is 2 pi RH for a cylinder. Our total surface area takes that lateral area. Oops, sorry. You got to do 2 of those bases, 2 pi r squared. And then you've got your volume formula, which is the area of your base, so pi r squared times the height. All right, plugging everything we know in, we're going to do 2 pi times my radius, which is 5, times my height, which is 15. And that gives me 2 times 5 is 10, and 10 times 15 is 150, so 150 pi. And my units were feet, so feet squared. All right, on the next one, we're doing 2 pi, or well, actually, I'm just going to write, this right here is the lateral area, so that's just going to be 150 pi plus pi, oops, sorry again, 2 times pi times my radius, which is 5, squared. So that's 150 pi plus 5 squared is 25, and 25 times 2 is 50, so 50 pi. So that gives me 200 pi. Those are like terms, so we can go ahead and add those together. They both have a pi attached, and then my units are feet squared. So that's your total surface area. And then your volume is pi times my radius squared times my height, which is 15. And when you multiply 25 times 15, you get 375 pi. Sorry, my dogs are making extra noises for you. Feet cubed. All right, so that's number 4. Let's do number 5. I'm going to pause this and move it up. Okay, on number 5, I went ahead and kind of drew a square pyramid just because I screw it up so much when I try to draw it, and it's still not the best, but whatever. So here's a square pyramid. It has a base with sides that are 6. Because the base is a square, each of these sides are 6. And then you have a height of 12. So remember, on a pyramid, your height is drawn, oh gosh, sorry. I did not mean to do that. Your height is 12, but it's got to be drawn from that apex up there, the vertex, and it's got to be drawn to the center of that square, and it's going to be perpendicular there. So when you draw this length right here, it's going to be half of that 6, so that's 3 right there. All right, and they told us that the height is 12, so this is 12 right here. Sorry, it's kind of blending in with that. I'm afraid if I erase it, though, yeah, I'm going to mess it up a little bit, but we'll try to fix it. So this is 12 right here. All right, now then you're going to need this lateral height, which is right here. And so to get that, we're going to have to do 3 squared plus 12 squared equals our c squared, or really our lateral height squared. And so that's going to be 9 plus 144, which is going to give us 153. So L squared equals 153. So then you're going to take the square root of that. And then that simplifies, that's the same thing as the square root of 9 times the square root of 17, which is going to be 3 square root of 17. So that's your lateral height. All right, so on our formula, what we're going to need is a capital P. The perimeter of our base is going to be 6 times 4, because we have 4 sides that are 6 each, and that's going to give me 24. The area of my base will be 6 times 6, which is 36. The height of the pyramid is 12. The lateral height of my pyramid is 3 square root of 17. All right, so for my formula, I need the lateral area, which is 1/2 PL. And then plugging that in, I get 1/2 24 times 3 square root of 17. So I'm going to do half of 24, which is 12, and 12 times 3 is 36 with that square root of 17 attached. And that would be that's an exact answer. My units are centimeters squared. Then we're going to do a total surface area, which takes that lateral area, and then it adds the area of your base. So why do I keep doing that? Sorry. So my lateral area is 36 square root of 17. The area of my one base we already figured out was 36. And then I can't add those together because they're not like terms. So that would be my total surface area. If I ask you for it to be exact, that would be your exact answer. If I ask you for a rounded off decimal, we would say it's 184.432 centimeters squared. All right, and then your volume is the formula is 1/3 the area of your base times the height. Again, my base is 36. The height of that pyramid is 24. So half of 36 is 18, and 18 times, why did I say 24? That's not right. Sorry about that. The height is 12. So a third of 36 is 12, and 12 times 12 is 144. So 144 centimeters cubed is my volume. All right. Number 6, we have a sphere. With a radius or a diameter of 16, which means my radius is 8. All right, so now it asks me to find, I don't have a lateral area because there's no base. I just have the total surface area, which is 4 pi r squared. So that's going to be 4 times pi, my radius is 8, so 8 squared. And then 64 times 4 is 256 with that pi attached, and my units are meters, so meters squared. So that's my total surface area. My volume formula is 4/3 pi r cubed. Volume is 3-dimensional, so that's why we cubed that radius. And then plugging it in, I get 4/3 times pi times my radius, which is 8 cubed. All right, so when you type it in your calculator, you can hit alpha y equals, and then choose option number 1 to make it look like a fraction. And then you're going to type it in just like this, 4/3, and then parentheses 8 cubed. And when you do that, your calculator will give it back to you as a fraction. You don't have to worry about getting a rounded off decimal. So you get 2048/3 pi, and my units are meters cubed. And that is my volume. All right, let's do some more. Okay, on number 7, we have the area of the base of a right cone is 144 square centimeters, and the height is 5 centimeters. So we know that this height right here is 5. I also know that the area of the base is 144, so that's our capital B. My capital B is 144 pi. Okay, when you do your formula, I mean, this one's just asking me to find the lateral area. And your formula for the lateral area is pi RL. So what we're going to need is to know what the radius is. I know what the area of my base is. It's 144 pi. Well, the formula for the area of my base, because my base is a circle, is just pi r squared. So I'm going to plug in what I know. I know capital B is 144 pi. I know on the right-hand side it looks like this. I'm going to divide both sides by pi. And so when I do that, the pi's cancel out. And I'm left with radius squared equals 144. So I'm going to take the square root of both sides. And when I do that, I get that the radius equals 12. So this is 12 right here. And now I can plug all that in to my formula. So pi times the radius, which is 12. Oh, well, I'm still short something. I still need to know what the slant height is, because that's the L right there, which is right here on your picture. So we're going to have to do the Pythagorean theorem. 5 squared plus 12 squared equals L squared. Or if you know that's a Pythagorean triple, you automatically know what it is. But this ends up being 169 equals L squared. Take the square root of that. Square root of 169 is 13. So this is one of those special right triangles. So my slant height is 13. And when you multiply 12 times 13, you get 156 with that pi attached. And then my units are centimeters cubed. All right, number 8. A cylindrical can contains tennis balls that have a diameter of 4 inches. Find the amount of wasted space in the can. All right, I'm going to pause this so I can draw this better. Okay, this is about as good as it's going to get. We've got 3 tennis balls basically inside of this cylindrical can. The diameter for those is going to be 4 inches, which means that one radius is 2 inches right there. All right, find the amount of wasted space in the can. So you need to know, we're basically doing the volume is what they're asking us to do when they talk about, filling up the can and the space that's empty in there. So your formula for that is going to be pi r squared h, because it's a cylinder. So you need a few things here. We're going to need to know what the cylinder's volume is, and we also need to know what the volume of each of the tennis balls are. Because what we're going to do is we're going to end up doing the cylinder's volume minus the 3 spheres volumes to see what the empty space is. Oops. Okay, so first thing this formula is for the cylinder. So we need to know the height of this cylinder. Well, the radius or the diameter for each of the balls is 4 inches. So that means that going this way, that's 4 inches. This way is 4 inches, and this way is 4 inches. So that's going to be 3 of those 4s, which gives me a height of 12. All right, so plugging that in my formula, I'm going to do pi times the radius squared times 12, which gives me, when I do 2 squared, it's 4 times 12 is 48. So 48 pi for the volume of that cylinder. All right, now let's do the tennis balls. I'm going to put here ball. So the volume for that is 4/3 pi r cubed. All right, so we're going to do 4/3 pi. My radius is 2, so we're going to cube that. So 2 cubed is 8. 8 times 4 is 32, and then divided by that 3. I'm just going to write it as 32/3 pi. And then you have 3 of those. So 3 balls will be 3 times 32/3 pi. Those 3's are going to cancel, and so you're just left with 32 pi. So that's the balls. So when we do the cylinder's volume, 48 pi, minus the 3 balls volume, and that's 32 pi, I'm going to get 16 pi, and then my units are inches cubed. So that's the volume of wasted space, or the amount of wasted space in that can. All right, next we have a spherical water tank. and it has a 40-foot diameter. So let me draw this. So if it's got a diameter that's 40, that means its radius is 20. How many gallons of water can be stored in the tank? That's volume. And it's a sphere, so we're going to do 4/3 pi r cubed for that. And the tank can be stored in the tank if 1 cubic foot is 7.5 gallons. So we're going to figure out how many gallons, even though our units are feet. So we'll worry about that here in a minute. First, let's figure out what the volume is using the information that we have. So we'll do 4/3 pi. My radius is 20, so 20 cubed. All right, when you calculate that, you'll get 4/3 pi, and then that's going to be 8,000 when you cube that. Oops. So volume equals 4 times 8,000 is 32,000 divided by that 3 pi. Okay, so that's our feet cubed. That's our volume. All right, you know that, and honestly, it's probably going to be easier to get that as a decimal. So I'm going to go ahead and write that it's 33,510.322 feet cubed. And I need to convert that to gallons. So they told me that 1 cubic foot, so I will write it like that, is the same thing as 7.5 gallons. All right, I'm multiplying it like that, so that way the feet cubes can cancel, and on my units I'll be left with gallons. And so when you end up multiplying that out, oh, hang on a second. Yeah. When you end up multiplying that out, you're going to get you're basically just multiplying that 32,510.322 times 7.5, and you get 327.412. Okay, that's if you had done it with a decimal. If we had done it using our actual fraction, what I would have done is 32,300. Or why did I say 300? Sorry. 32,000 divided by 3 pi, and you're going to be multiplying that by your 7.5 basically, but really 7.5 as a fraction is 15 halves, and so when you multiply that out, you're going to end up getting you'll multiply 32,000 over 3 times 15 over 2, and it ends up being 80,000 pi gallons. So that's an exact answer right there, and this is a rounded off answer right here. Either answer is right though. Okay, on the next one, let me pause it a second and move this up. Okay, on the next one, number 10, it's using, oh, I forgot to change that number. Darn it. If 1 gallon of paint covers 300 square feet, how many gallons will be needed to give the tank in number 10 1 coat of paint? I meant number 9, sorry. So this is the same sphere picture that we're going to be working with. But we're going to do the sphere surface area. And that formula is 4 pi r squared. So again, we found out our radius was 20, so 20 squared. 20 when you square it is 400, and 400 times 4 is 1,600, so 1,600 pi, and that's going to be feet squared. All right, so that's our surface area. Then we're told 1,600 pi feet squared. 1 gallon is covers 300 square feet. So to figure out how many gallons of paint we need, those feet squared cancel. I'm basically doing 1,600 divided by 300. So those zeros will cancel out, and we're left with 16 over 3 pi. And as a decimal, you're going to need to know that this time. It's 16.755, which means that we're going to need 17 gallons of paint to cover that. All right, on number 11, we have a sphere inscribed in a cylinder. All right, let's see. Here's my sphere. here's my cylinder. Okay. If the diameter of the sphere is 8, so that means my radius is 4, find the amount of wasted space in the cylinder. All right, so we're going to do the cylinder's volume, which is going to be the area of your base times your height, so pi r squared h. And then it's going to be pi times 4 squared. Now this sphere is inscribed in the cylinder. That means that it's touching on top, on the bottom, on the sides. And so that means that, if your diameter is 8, that means this height of the cylinder is also 8. So that's going to be right here. That'll be 8. And then we're doing 16 times 8, which is 128 pi feet squared. Feet cubed, sorry, it's volume. All right, the sphere's volume, that formula is 4/3 pi r cubed. All right, so you're going to do 4/3 pi. My radius is 4, so 4 cubed. And so you'll do 200, when you multiply 4 cubed, which is 64, times 4, you get 256 divided by 3 pi, and then the units there are feet cubed. Okay, so your wasted space will be you subtracting those amounts. So you're going to do the 128 pi minus 256 divided by 3 pi, which, you could get a common denominator and subtract it like that. So 100, you need to, multiply this by 3/3. You can do this in your calculator too. But let's see, that gives you 4, 8, 3/3 pi minus 256 pi over 3. And so when you subtract those, because they both have pi, you're able to subtract that, and you'll be left with 128/3 pi. And then again, our units are feet cubed. So that's how much wasted space there is in a cylinder. Okay, this next one, it's going to take some space, so I'm going to erase all of this. Okay, on this next one, this one's a little bit tougher. We've got a cylinder with a 3-foot diameter is bored through a prism in which the bases are equilateral triangles with sides of 14 feet and a height of 10. Find the surface area of the figure. So if you think about this, you have the outside surface, which is normal, like you normally calculate, but through this right here is a hole inside of that shape. So when you drill through that, you still have surface area inside that hole. So when we calculate this, we're going to be doing the surface area of the triangular prism. You got to calculate it, but then you've got to subtract out the 2 circles that you have. And so because you've calculated, like all this surface right here when you do that, but you've got to take out that circle right there on both ends. So you got to subtract out the area of those 2 circles. But then you need to add the lateral area of the cylinder on the inside, because that's more surface that you have on the inside that you need to include. So this is basically what we're going to be calculating. So for the triangular prism, our formula is capital P times H plus 2 times B. So for this shape, I need to know what capital P is. I know that I'm going to erase that arrow, sorry. Each of our triangles have a side of 14. And then the height of this prism is 10. So if you think about that, we've got, I'm going to draw it over here. We've got an equilateral triangle where each of these are 14. I know that when I draw this height, it's going to break this up into 7 and 7. So I can do 7 squared plus the height squared equals 14 squared. Remember, your 14 has to be the C because it's across from your right angle. So when you calculate that, you're going to get the square root of 147, which, by the way, is the same thing as the square root of 49. Oops, sorry. Goodness, I cannot write that for some reason. Square root of 49 times the square root of 3 which ends up being 7 square root of 3. So that's your height for this triangle. So when you calculate what you need, the area of that triangle, you're going to do 1/2 the area of the base, or the base times the height. So 1/2, the base is 14. The height we just figured out was 7 square root of 3. And so half of 14 is 7, and 7 times 7 is 49. So the area of your base will be 49 square root of 3. And I'm going to erase this capital A right here because I want you to think of that as capital B. It's the area of your base. All right, the perimeter of that triangle is 14 times 3, which is 42. All right, so I should be able to plug those things in. So the perimeter is 42. The height is 7 square root of 3, plus 2 times the area of my base, which I found out was 49 square root of 3. So my total surface area, oh, you know what? I screwed up. Sorry. Let me erase this. Because what I did when I calculated this, I did the perimeter, which is 42. When I did the height of the triangle. This height right here is the height of the prism, so I should be using this 10 right here. So 42 times 10. Sorry about that. And then the area of my base is 49 square root of 3. So 42 times 10 is 420 plus 98 square root of 3. Oops. Okay. And I can't do anything else really with that unless I made it a decimal, but I'd rather keep it exact. And so that's the total surface area. That's this part of what we're trying to find. So right now we've got 420 square root of, oops, that's crazy. 420 plus 98 square root of 3. Now I need to find the area of the two circles. It tells me, what does it tell me? How do I know? Oh, the cylinder has a 3-foot diameter. That 3-foot diameter hole bore through it. So let's see. If I'm going to do the area of my circle, I'm going to just say circle area. I'll say area and then a little subscript circle there. So circle area is going to be pi r squared. My radius, my diameter is 3. So my radius is 3 over 2. It's 3/2 or 1.5, however you want to do it. I'm going to keep it exact. So it's going to be pi times 3/2 squared. You can get a decimal if you'd rather. 1.5 squared is 2.25. But I'm going to just square that. So 3 squared is 9 with a pi attached and a 4. I'm going to keep it like that for now. So this ends up being 9 pi over 4 times, well, actually I need to do 2 of those. So 2 times 9 pi over 4 gives me 9 pi over 2. So that's what the two circles areas are. So let me erase this and just replace it with that. So 9 pi over 2 is my circle area that I'm going to be subtracting. Okay, and then we also have our inside part there. So we need to do the lateral area of the cylinder, which is 2 pi RH. So 2 pi, the radius of that was 3/2. And then the height is also going to be 10, because you've got this 10-foot cylinder that goes through that triangle right there. So 2 times 3/2 is just 3. You're doing 2 times 3 divided by 2, which would give you 3. And then 3 times 10 is 30. So 30 pi is, oh goodness gracious, I just realized something I did wrong. Oh no, I didn't. I just need to show that that's minus and this is plus. And then that's going to be 30 pi right there. All right, things that I can add together. I can add this 30 pi and this 9/2 pi because they're like terms. So when you do that, you're going to end up with 420 plus 98 square root of 3. That 30 pi is the same thing as 60 pi over 2. And then you can subtract that 9 pi over 2 from that. So you get plus 51 pi over 2 feet squared. Now you could get the decimal as well, but that's an exact answer. All right, and you can't combine any of those further because there's no more like terms. All right, let me do another one. Okay, on this one, I'm not even going to draw a picture. It gives me a sphere has a surface area of 100 pi square inches, and it wants me to find the volume. So I know I've been given the surface area, and that formula is 4 pi r squared. I'm going to plug in what I know. So 100 pi equals 4 pi r squared. Now the reason why I'm doing this is because I'm trying to find the volume, and the volume of a sphere is 4/3 pi r cubed, which means I need to know what the radius is, and this is going to help me get that radius. So I'm going to divide both sides by pi, and when you do that, the pi's cancel. Then I'm going to divide both sides by 4. I guess technically I'm dividing by 4 pi on both sides. So the 4's and the pi's cancel on that side, and then over here, 100 divided by 4 is 25. And that equals the radius squared. So the radius equals 5 when I take the square root of that. All right, so now we can go over here and we calculate that. Volume equals 4/3 pi, and my radius is 5, so that'll be 5 cubed. Okay, so when you multiply that out, 5 cubed, that's supposed to be a 3, sorry, is 125, and 125 times 4 is 3. I'm sorry, 125 times 4 is 500. 500, I was thinking in my head, over 3, sorry about that. Pi, and then you've got inches cubed as your unit. All right, there's that one. Okay, on the next one we have determine the surface area of the remainder of a cake that is 6 inches high and 10 inches in diameter after Mr. Piggy eats a 45 degree slice. Let me see if I can draw this picture. Hang on just a second. Okay, on this one we have they're asking us to find the surface area of the remainder of the cake that is 6 inches high with a 10-inch diameter, so 5-inch radius, after Mr. Piggy eats a 45 degree slice. So 45 degrees has been taken out of that. 45 of the whole circle, so there's 360 degrees in a full circle. That's a 1/8. So they've taken out 1/8 of the circle, which means 7/8 is left. All right, so if we calculate the cylinder's total surface area, my formula is 2 pi RH plus 2 pi r squared. So we'll do 2 pi, my radius is 5, the height is 6. All right, so 2 times 5 is 10, times 6 is 60, so 60 pi, plus 25 times 2 is 50. And that gives me 110 pi. Now we've only got 7/8 of that, so we're gonna do 110 pi times 7/8, and that's gonna give me, when I multiply that out, 385 pi over 4. All right, so that's the total surface area. If you just kind of calculate 7/8 of it being left. The only thing is you still have these rectangles right here that are part of the surface that we wouldn't normally calculate. So we've got to calculate those 2 rectangles. So we can add those back in. So those rectangles are going to be this length of 5 right here and a height of 6. So we're going to do 2 of those rectangles that are 5 by 6. And that gives you 60. And so your final answer for the total surface area is going to be 385 pi over 4 plus 60 inches squared. And that's your answer. All right, on the next one, find the amount of saran wrap needed to cover a half grapefruit that is 5 inches in diameter. So this time we have a hemisphere. The diameter is 5, so that means my radius is 5 halves. Or 2.5, whichever way you want to think about it. Okay, so you're going to do the surface area of a sphere, of half a sphere, plus the circle top. So my formula for a sphere surface area is 4 pi r squared, which I'm going to multiply by half, plus the circle top, which is pi r squared. So half of 4 pi r squared is 2 pi r squared. but you still need to add a pi r squared, and you get 3 pi r squared. So now we just need to calculate that. So when I do 3 pi times r squared, I get 3 pi, my radius is 5/2 squared, so that's 3 pi. When you square that, you get 25/4. And so you'll end up with 75 pi over 4 inches squared for my answer. All right, last problem. We have the volume of a rectangular prism is 162 cubic inches. So let me draw that. Okay, so that's the volume, and we're doing a rectangular prism, so that's going to be the area of your base times the height. If the width is twice the height and the length is 1.5 times the width, find the dimensions of the prism. So let's see. If the width is twice the height, so our height is right here. I'm just gonna call that x because they are doing it with relationship to this. So the width is twice the height, so I'm gonna make this 2x. Obviously my drawing is not to scale. And the length is 1.5 times the width. So my length is 1.5x. All right, so my capital, I'm gonna write it here. My height equals x. My width equals 2x, and my length equals 1.5x. All right, so the area of your base is going to be length times width. So basically your formula is length times width times height. So we're going to do length, which is 1.5x, times the width, which was 2x, times the height, which is x. When you multiply 1.5 times 2, you get 3. And when you multiply x times, when you multiply x times x times x, you get x cubed. So that's going to be 3x cubed. Now they told me the volume is 162. I should have replaced the volume with that. So 162 equals 3x cubed. I'm going to divide by 3. Oh, what did I do wrong? Okay, I figured out what I did wrong. I'm sorry. Let me erase some things. First of all, let me erase all of this right here. Sorry about that. Okay, sorry, it's late. All right, it's right here on the length that I messed up. Okay, so it tells me the length is 1.5 times the width. So I'm going to be doing 1.5 times the width, which is 2x. And when I multiply that out, I get 3x. So my length is actually 3x. Sorry about that. So my volume is 162. My length is 3x. My width is 2x. And my height is x. Okay, when I multiply that out, I do 3 times 2, and I get 6. X times x times x is x cubed. All right, divide by 6. So that equals x cubed. When you divide 162 by 6, you get 27. When you take the cube root of 27, you get 3. In your calculator, if you want to take the cube root of something like 27, you can raise it to the 1/3 power. That's one option. Another option is to hit on your calculator math option number 4, which will be the cube root. And then you just put 27 in there. So that's how you can take the cube root of that, and you get 3 when you do it. But just make sure y'all know how to do that. Okay, so now then I know x equals 3 because it's just wanting to know the dimensions. So my height equals 3, my width equals twice as long, so that's 6, and then my length is going to be 3 times that, which will be 9, and then each of these units were inches. All right, that's it for this assignment. Thanks, guys.